This is video 3 of section 3.2, and I kind of cut off the problem a little bit when I copied this into the program, and so I went ahead and wrote it out. Hope that's readable, legible for everybody. What they did is they gave us the equations for the functions. When they give you an expression to tell you what the function equals, what they're doing is they're giving you a rule or a way to be able to calculate the actual function value. And so, like on number 54, when it says f of -1, they're wanting you to plug -1 in as the input into this function, and the input is the x value. So, when I plug that in, I'm going to have 3 times -1 plus 3. All I did is I substituted the -1 in for x. Now this f of -1 is a label. Do not try to do some kind of multiplying or dividing or whatever with this. This is just telling you the function when you plug in -1. It's just a label. It's like saying y when we plug -1 in. Okay? Please don't try to divide by -1 to get just f by itself, or don't be trying to multiply f times -1 or any of that thing. This is a label saying this is a function plugging in -1. Okay, I don't know how many more ways or different ways I could say that. So here we go. 3 times -1 is -3, plus 3 is 0. So f of -1 equals 0. With an input of -1, the output is 0. So it's actually pretty simple, isn't it? Okay, I'm going to change colors so that you know I'm on a separate problem. Number 56, it says h of 0. So I'm going to look at the function that was h of x, which is right here, is the one I rewrote. I'm going to plug 0 in for x, because 0 was the input they want us to use, and the variable for the inputs is x. 0 to the second power is 0, times 5 is 0, minus, oh here, I'll go ahead and write that down. We'll do it in 2 steps. 5 times 0 is 0, minus 7 is -7. So h of 0 equals -7. Alright, next one, that's number 58. G of 1, that means in the g of x function, I'm going to substitute x for 1. Or I guess I'm actually substituting 1 for x, but anyway. One squared is going to be 1. So 4 times 1 minus 6 times 1 plus 3. This term here, 4 times 1 is 4. -6 times 1 is -6, and this is plus 3. 4 minus 6 is -2, plus 3 is +1. Okay, on number 60 I have another h, so I'm going to erase this stuff. Oh, I should erase that. H was 5x squared minus 7. And when it says h of -2, that means it wants me to find the function value for -2. So I'm going to substitute -2 in for x. And I'm going to calculate. -2 squared is 4. 5 times 4 is 20. And 20 minus 7 is 13. These problems down here are the same type. All they want you to do is try 3 different inputs instead of just 1. Okay? So that was number 60 I just worked. I'm going to move this up a little bit if I can get a hold of it. Okay. Alright, so for number 62, if I do g of 0, that would be -1/3 times x, which is 0. Negative 1/3 times 0 is 0. G of negative 1. Let me change colors here. That way you can see what I'm doing. Negative 1/3 times x, in this case, is negative 1. Negative times negative is positive 1/3. This is kind of like when we were doing our, well, it's not kind of, it's exactly like what we were doing when we were graphing and doing the input-output table so we could make a graph. We were choosing different x values and putting them in. Well, that's what we're doing, except for this actually has a label on each one letting me know what I plugged in. Okay, I can either do 3 divided into 3 is 1 times negative 1, or I could have said negative 1 times 3 is negative 3 divided by 3 is negative 1. Either way, it's negative 1. If I wanted to make an input-output table to show this function, I would just do it like this. So for the x values of negative 1, 0, and 3, negative 1 produced 1/3. 0 gave me 0. And 3 gave me negative 1. The book doesn't ask you to do that, but not a bad way to show your answers. Okay. My next function I'm going to do is h of x is number 64. It says h of x is equal to negative x squared. The first one it wants me to try is negative 5. Make sure that you put the negative 5 in parentheses so you know that it's being squared, and don't confuse it with this minus in the front. Negative 5 squared is positive 25, so I have minus positive 25, which is negative 25. So input of negative 5 gives us negative 25. I'll change colors here. Now I'm going to put in negative 1/3. Again, I'm using parentheses to make sure that I square my negative here. Negative 1/3 times negative 1/3 is positive 1/9. So I have a negative out front and then a positive 1/9. And negative 1/9 is going to be negative 1/9. Alright, same thing. This time we're using positive 1/3. The reason these are functions is no matter how many times I plug that same value in, like when I plug negative 1/3 in over and over and over, I will continue to get negative 1/9. So, and the same thing with this. If I plug 1/3 in over and over and over, I should get the same value every single time. That's what makes it a function. All right, 1/3 squared is 1/9, so I have negative 1/9. It's negative 1/9. I could make me a table like I did before. I'm not going to this time. Okay. Now I'm going to do number 66. On number 66 it says h of x is equal to 7. That means the function equals 7. And then it wants me to calculate the function if x is 7. Well, if x is 7, it doesn't really matter. The output is 7. If if x is 542, I'm going to plug in 542 for x. Well, there's no x, so my output is still 7. It says the function equals 7. This is what we call a constant function. No matter what your input is, no matter what your x is, we're always getting a y value of 7. If you was to graph this, it would be a horizontal line at y equals 7. So anyway, that's it for number 66. They all equal 7. Okay, number 68. Okay, I don't have a calculator on me, so I may not do some of these calculations for like 7.2, but I will go ahead and do the first two, which is g of 1. Because I believe I can probably do that one in my head. I substitute 1 in for the x values. 1 squared is 1, so 2.7 times 1 is 2.7. 6.8 times 1 is 6.8. 2.7 plus 6.8 is 9.5, and when I subtract 10.2, I believe I get negative 0.7. So input of 1 gives us negative 0.7. The next one is negative 5. 2.7 times negative 5 squared plus 6.5 times negative 5 minus 10.2. Okay, I may have bitten off more than I can chew here. 2.7 times negative 5 times negative 5 is positive 25. 6.5 times negative 5 is negative 32.5. Minus 10.2. All right. Uh, 13, 0, 14, 5, 5, 7, 6, 1 decimal place, 67.5 minus 32.5 minus 10.5, 10.2, sorry about that. 67.5 take away 32.5 is 35. And if I subtract 10.2 from that, I still want to call that 10.5. 24.8.